Hello everyone. Happy New Year to all of you. Good evening. Good evening everyone and welcome to the class. So today is marathon class for electrical machine. Let's start the session. In this session, I have taken the questions from transformer, DC machine, induction motor and the synchronous motor and alternator. So let's start the session. It is about me. I am Vijay Bansal, 20 plus years of teaching experience and 6 times gate ranker, 4 times in electrical and 2 times in electronics. Good evening everyone. So let's start the session with the first question. The reactance in a single phase 100 kVA 2200 oblique 220 volt transformer is zero point 0.4 per unit. It is the reactance. X per unit is zero point 0.4 and the full load copper loss is 10 kilowatt operating at zero point 0.8 lagging. The voltage regulation in percentage of the transformer at full load. You have to calculate the voltage regulation and datas are given in the per unit form. And 4 options are given. You have to give the correct option. So start the session and solution of the first question. Yes, good evening Ashok, good evening bache, very good evening and happy new year to you. So in this question it is given as X per unit, reactance per unit is given as 0.4 and if the rotor copper loss and the kVA is given, rated kVA is given, we can calculate the R per unit. Resistance per unit we can calculate R per unit is rotor copper loss upon the rated kVA. Resistance per unit of the transformer is rotor copper loss divided by rated kVA. And if we calculate in this transformer R per unit, resistance per unit we can calculate is 10 upon 100, that is 0.1. That is 0.1. Power factor is given as 0.8 lagging. Load power factor is given as load power factor cos phi is given as 0.8 and it is lagging. 0.8 lagging. 0.8 lagging. And if the transformer load is given, power factor R per unit, X per unit is given, so we can calculate the voltage regulation in terms of per unit is R per unit cos phi, resistance per unit cos phi plus. If it is lagging load, it would be plus. If it is leading load, it is minus. So there is a plus minus, both sign may be there, but it is a lagging load, so it is plus. And X per unit sin phi. And if you want to calculate in percentage, you have to multiply by 100. So you may write for lagging load it is plus. For lagging load sign is positive and for leading load sign is negative. So if you write, you can calculate R per unit. We have calculated 0.1, cos phi is 0.8 plus X per unit is given as 0.4 and sin phi. If cos phi is 0.8, sin phi is 0.6. So it is 0.08, 0.08 plus 0.24. If you add, you are getting 0.32. It comes 32%. If you want to calculate in percentage, it is 32%. Because 0.32 is the voltage regulation. But if you calculate percentage voltage regulation, so percentage voltage regulation is 0.32 multiplied by 100. So it is 32%. So correct answer of this question is 32%. Because zero point 0.1 multiplied by 0.8 is 0.08 into 0.24. And if you add, you get 0.32. And in the percentage form, it is multiplied by 100, so you get the 32%. So voltage regulation is 32%. Because rotor copper loss is given as 10 kilowatt and rated kV of the transformer is 100. So R per unit is 10 upon 100, that is the 0.1. Okay, moving to the next question. A 400 volt, 50 hertz, 4 pole, 1440 RPM star connected squirrel cage induction motor is controlled by V by F control. You must know the concept of V by F control, and the frequency is reduced to 30 hertz. The percentage slip at 30 hertz frequency is. So for speed control, we are using the V by F control. And if we are using the V by F control and frequency reduced to 30 hertz, so what is the percentage slip at 30 hertz? You have to calculate. So if I solve, initially, you must know in the V by F control, slip control, speed remains same. So you must note down in V by F control, slip speed must remain constant. Slip speed SNS, slip speed NS minus NR remains constant. Slip speed remains constant. If you know this fact, you can solve this question very easily. Slip speed remains constant. In the V by F control method, slip speed remains constant and slip speed is nothing but NS minus NR or SNS, because NS minus NR is nothing but SNS. So in the case 1, if I solve for case 1, from the case 1 I am calculating the slip speed. So it is a 4 pole 50 hertz. So synchronous speed NS is equal to 120 F upon P. So it is 1500 RPM. So 120 multiplied by 50 divided by 4. So it comes out 1500 RPM. NR, rotor speed in RPM is given as 1440. First case you can calculate orally. I am solving mathematically, but you can solve orally. Because if the 50 hertz 4 pole induction motor synchronous speed is 1500 RPM, and if the NR is 1440, slip is 4%. You can calculate easily, 4% is the slip. So if you calculate NS minus NR, slip speed in the first case is NS minus NR. NS is 1500, NR is 1440, so it is 60 RPM. 60 RPM. It is the slip speed which is called S times NS. In the first case, or you may calculate the slip of the first case as well, because if you calculate slip as NS minus NR upon NS, you get 4% is the slip. Slip you are getting 1500 minus 40 divided by 1500. So it comes out 0.04, or in the percentage form it is 4%. It is so easy. But in the second case is if the frequency, supply frequency is reduced to 30 hertz. Now we are reducing the supply to 30 hertz. And if the supply frequency is 30 hertz, pole remains same. In the V by F control, always pole remains same. So NS will change. NS will change. So what is the NS now? In the case 2, when the frequency is, second case when the frequency is 30 hertz. So what is the NS? NS is equal to 120 F upon P. Once again, I am applying the formula with the different frequency 30 hertz. So I am getting 150 or 120 into 30 divided by pole. Number of poles are 4. So it is 900. It is the 900. But SNS remains same. Slip speed remains same in both cases. So what is the slip speed? Slip speed is equal to S time NS is equal to 60. In the V by F control, and SNS remains same. So what is the S? S we have to calculate slip. New NS is 900 is equal to 60. So what you are getting? New slip is equal to 6 upon 90 or 2 by 30. 2 by 30 if you calculate, you are getting 2 by 3. In the percentage form if you calculate, 2 by 30 into 100. 20 by 3. 20 by 3% is 6.67%. So new slip change from 4% to 6.67%. So in the V by F control, if the frequency change from 50 hertz to 30 hertz, the slip change from 4% to 6.67%. So correct answer of this question is the new slip at the 30 hertz frequency is 6.67%. Now moving to the next question. A 600 kVA transformer has an efficiency of 90% at full load as well as at half load also. Means at full load as well as at half load, efficiency of the transformer is 90%. Both at unity power factor. In both cases, load is at unity power factor. The value of 2 Pi plus Pc will be how much kilowatt? Where Pi is the iron loss and Pc is the full load copper loss. So you have to calculate 2 Pi plus Pc. So it is procedural question. First you have to, from this given two condition, first you calculate the Pi and Pc and then add 2 Pi plus Pc and get the required answer. So I am solving. I have taken the data such that calculation becomes simpler. I have taken the data so that the calculation becomes simpler. Because in the gate, calculation always becomes simpler. Data is given such that. So I am solving. In the first case, at full load, you know very well, efficiency at general load, efficiency of transformer at general. It is easy question. It is basically easy question. You can solve easily if you know the formula. Efficiency of transformer at general load if you calculate the efficiency of the load at general load, it is eta is equal to x V2 I2 cos phi 2 divided by x V2 I2 cos phi 2 plus Pi plus x square Pc. I hope everyone knows this formula of the efficiency of the transformer at general load. Now, first case full load, second case is half load. And in both cases, cos phi 2 is 1, unity power factor. In both cases, load power factor is unity power factor. So, case 1, at full load, x is equal to 1. At full load, x is equal to 1. If I put x is equal to 1, efficiency is 90%. So, eta is equal to 0.9. 0.9. 90% can be written as 0.9 is equal to X full load 1 into V2I2. V2I2 is given as 600 into cos phi 2 is 1 upon X V2I2 cos phi 2, again it is 600 plus Pi iron loss plus X is equal to 1 full load copper loss is Pc. So if you make the equation, it becomes 600 plus Pi plus Pc is equal to 600 upon 0.9. 6000 upon 9, or you can write 2000 upon 3. So what is the Pi plus Pc value? Pi plus Pc is equal to 2000 by 3 minus 600. 2000 by 3 minus 600. 600 3 the 1800. 2000 minus 1800 is 200 by 3. So first equation is Pi plus Pc is equal to 200 by 3. It is the first equation. So Pi plus Pc is equal to 200 by 3. Since I have made this equation general equation 1, I am getting it is as 2. I am marking this equation as second equation. Now if Pi plus Pc is 200 by 3, in the second case, at half load. Case 2, at half load. At half load, X is equal to 0.5 या 1 by 2. Again, the efficiency is same. So, eta 0.9 is equal to X V2 I2 cos phi 2. 1 by 2 into 600. Again, unity power factor upon 1 by 2 into 600 into 1 plus Pi. Iron loss does not depend on the load. Plus Pc. Copper loss is squarely proportional to load. So, X square Pc. X square is 1 by 2. So, 1 by 2 square is 1 by 4. I am putting value of X as 1 by 2. So 1 by 2 square is 1 by 4. So I am getting 1 by 4 into Pc. Now if I solve, I am getting 300 plus Pi plus Pc by 4 is equal to 300 divided by 0.9. 300 divided by 0.9. And if I solve, I am getting 3000 upon 9 or 1000 by 3. So Pi plus Pc by 4 is equal to 1000 by 3 minus 300. 1000 by 3 minus 300 is 1000 minus 900, that is the 100 by 3. It is the equation number 3. Now if I solve equation 2 and equation 3, Ashok is giving the answer. Very good Ashok, very good bache. So I am also solving. Now I am getting two equations. Pi plus Pc is equal to 200 by 3. That is the equation 2. That is the equation 2. Pi plus Pc is 200 by 3 and Pi plus Pc by 4 is 100 by 3. Pi plus Pc by 4 is 100 by 3. And if I solve, I am getting 3 Pc by 4. 3 Pc by 4. Yes, Abhishek is also giving 88.88%. Very good, bacho, very good. So it is 3 Pc by 4 is 100 by 3. So it is Pc is equal to 400 by 9. 3 Pc by 4 is equal to 100 by 3. So it is 400 by 9 kilowatt. And what is the Pi? Pi is equal to 200 by 3 minus Pc. Pc is 400 by 9. I am getting 600 minus 400, 200 by 9. Once I calculated the Pi and Pc both, now I have to calculate 2 Pi plus Pc. And 2 Pi plus Pc is 2 times 200 by 9 plus Pc. Pc is 400 by 9. So I am getting 800 by 9. And if you solve 800 by 9, I am getting 88.88 or up to 2 decimal point, it is 88.9 kilowatt. So correct answer of this question is 88.89 kilowatt. So correct answer is 88.89 kilowatt. So Abhishek, Ashok both have given the correct answer. Now moving to the next question. Now I am moving to the next question. This question is related to the relative speed between the rotor structure, stator structure, rotor field. So a three-phase, six-pole, 50 hertz induction motor has a full load speed of 960 rpm. The speed of the rotor field with respect to rotor structure you have to calculate. First, speed of the rotor field with respect to rotor structure. Three answer you have to give in every option. Second is speed of rotor field with respect to stator structure. Second one. And third one, speed of rotor field with respect to stator field. You have to calculate three speeds, and rotor speed is given 960 rpm, 6 pole 50 hertz induction motor. So it is easy question. If you know the concept of relative speed, you can give the answer very easy. So if I solve, the data given is, in this question, data is given as 6 pole 50 hertz. And if the 6 pole 50 hertz, ns is 1000 rpm. Or in fact, you can calculate ns is equal to 120 f upon p. So it is 120 multiplied by 50 divided by pole. Number of poles are 6. So it is 1000 rpm. It is 1000 rpm. ns is 1000 rpm. And rotor speed, full load speed of the rotor is 960 rpm. Means NR is given as 960 rpm. So second, NR is given as rotor speed. NR is equal to 960 rpm. Now you have to calculate the speed of the rotor field with respect to rotor structure. Means you have to calculate speed of rotor field with respect to rotor structure. So rotor field minus rotor structure is the relative speed between rotor field and rotor structure. So rotor structure is the mechanical speed, that is 960, and stator field and rotor field both runs at the synchronous speed. So you must know rotor field as well as stator field both runs at the synchronous speed. So between the relative speed between uh, rotor field, rotor field and rotor structure. Rotor structure. Rotor structure means rotor, mechanically rotor. So how much speed of the rotor field? Rotor field speed is 1000 rpm. That is the synchronous speed. And what is the rotor structure speed? Rotor is running at 960 rpm. Yes. So it is, Abhishek have given all three answers correct. Very good, Abhishek. Very good, bache. So correct answer is 1000 minus 960. 1000 minus 960 means the speed of the rotor field is 1000. That is the ns. Rotor field speed is ns. And rotor speed is nr. So correct answer is ns minus nr. So 1000 minus 960 is 40 rpm. First answer is 40 rpm. Now I have to calculate the second. Second is we have to calculate rotor field speed with respect to stator structure. Rotor field speed with respect to stator structure. So stator is static basically. So rotor field speed, second, rotor field speed with respect to stator structure. Stator can be taken stator structure, both are same. Stator structure. So rotor field speed is ns and stator structure speed is 0. So correct answer is ns minus 0 because rotor field is running at the synchronous speed and stator is static. Stator is not running at all. So it is 1000 minus 0. 1000 minus 0 is 1000 rpm. So relative speed is 1000 rpm. Now the third case. Third case is rotor field speed with respect to stator field. And rotor field with respect to stator field is stationary because both are running at ns speed. Both are running at ns speed, so relative speed is zero. So rotor field speed with respect to stator field speed, stator field speed. Field means magnetic field. So rotor magnetic field speed is ns and stator magnetic field speed is ns. So what is the relative speed? Ns minus ns. Ns minus ns, that means 1000 minus 1000. 1000 minus 1000 is 0. 0 RPM. So correct answer is 40,000 0. Means rotor field speed with respect to rotor structure is 40 RPM. Rotor field speed with respect to stator structure is 1000 RPM. And rotor field speed with respect to stator field speed is 0 RPM. So correct option is A option is the correct answer. So Ashok and Abhishek both again have given the correct answer. Now moving to the next question. And the next question is, it is also very good question related to the induction motor. A three-phase delta connected 4-pole 50 hertz induction motor has a stator resistance is 0.4 ohm per phase at the operating temperature. If for a line current of 20 ampere, the total stator input is 4000 watt. Means power input to the stator is 4000 watt. Then the internal torque. You have to calculate the electromagnetic torque, that is called internal torque. Neglecting stator core loss will be how much Newton meter? So this question is easy. If you calculate the PG is equal to T into omega s. So this question is so easy. Once you calculate the air gap power, using the air gap power, you can calculate the internal torque. Because internal torque or electromagnetic torque multiplied by synchronous speed is after PG, air gap power. So using this formula, you can calculate the internal torque or electromagnetic torque. What is the? We know that we know that PG, air gap power, is equal to electromagnetic torque multiplied by omega. T electromagnetic torque is also called internal torque. So what is the electromagnetic torque? Electromagnetic torque is Pg upon omega. And now what is the air gap power? Air gap power is the stator input power minus stator loss. So Pg, air gap power is equal to stator input power minus stator loss. And stator loss are consist of stator core loss, stator copper loss. But core loss is neglected here. Stator loss constitute two components. One is the stator iron loss and second one is the stator copper loss. But in this question, neglecting stator core loss. Stator core loss are so low that they can be neglected. So what is the PG? PG is equal to stator input power. Stator input power is 4000 minus stator copper loss. Stator copper loss. Stator copper loss. So it is a delta connected. The motor stator is delta connected and line current is given 20 ampere. So in the delta connection, if line current is 20 ampere, phase current is 20 by root 3. And since it is a three phase, so stator copper loss is 3I square R and R is given as 0.4 ohm per phase. So if I calculate, it is so easy. It is 4000 minus 3 times because it is a three phase induction motor into IPH. IPH for a delta connection is IL by root 3 square multiplied by zero point 0.4 because stator resistance per winding resistance is 0.4 ohm per phase. If you solve mathematically, you are getting 4000 minus root 3 square 3, 3 3 cancel out, 200 का square 400 multiplied by 0.4. So you are getting 4000 minus 160. 4000 minus 160 is 3840 watts. So we have calculated the PG. This is called air gap power. Now what is the omega? There is a 4 pole. And if it is a 4 pole motor, so NS is equal to 120 F by P. 120 into 50 divided by 4, that is the 1500 RPM. But we have to calculate omega S. So omega S is 2 pi NS by 60. We have to convert. Yes, Ashok, your answer is correct, bache. Very good. So 2 pi into 1500 divided by 60. So it is 50 pi. It is 50 pi. Now PG is known, omega S is known, so you can calculate the T. Electromagnetic torque is PG upon omega S. So if you put the value of PG and omega S, you get the answer. And Ashok have given the answer correctly. So power we have calculated as 3840 divided by omega S. Omega S is the 50 pi. And if we solve, we get the correct answer. And Ashok have given the answer 24.4. I think it is correct. I am also checking cross divided by 24.446. So you can write 24.45. Up to the 2 decimal point, it is 24.45 Newton meter. So correct answer of this question is 24.45 Newton meter. This is the correct answer of this question. Yes, Abhishek, again, bache, you are absolutely correct. Okay, moving to the next question. Yes, again, this question is related to induction motor and power flow diagram. This question is again from the power flow diagram of induction motor. A 6 pole 50 hertz 3-phase induction motor is running at full load. Develop a useful torque. Useful torque means shaft torque is 150 Newton meter at a rotor frequency of 1.5 hertz. What is the shaft power output in kilowatt? So easy question. So you can easily calculate. Useful torque is given, that means shaft torque is given. And we have to calculate shaft power. So what is the shaft power? Shaft power using the power flow diagram of the induction motor, shaft power is shaft torque multiplied by omega. This is the formula. This is the formula we have to use. Shaft torque is directly given. Useful torque at the shaft means it is the shaft torque, that is 150 Newton meter. We have to calculate the omega. And rotor frequency is given. Using the rotor frequency and stator frequency, supply frequency, we can calculate the slip. Because omega r is nothing but it is the omega s 1 minus slip. Omega s into 1 minus slip is the omega. So slip you can calculate using the rotor frequency and stator frequency or supply frequency. So how can we calculate the slip? We know that rotor frequency is equal to slip times stator frequency or slip times supply frequency, because supply and stator frequency remain same. So F2 is 1.5 slip times frequency and supply frequency is 50 hertz. So if I calculate what is the slip is equal to 1.5 divided by 50. So it is the 3% or 0.03. Slip is 0.03. What is the NS? NS you can calculate 120 F upon P. Now pole. Pole is given as 6 pole and 50 Hertz for 1000 RPM you can write directly. It is the 120 into 50 divided by 6. So it comes out 1000 RPM. Now you can calculate omega R S is equal to 2 pi NS by 60. because we are calculating in the radian per second. So it is 2 pi multiplied by 1000 divided by 60. Machine questions are little bit calculative. You already know in the machine questions or power system question, you have to do a little bit calculation. So you must be mentally ready that we have to do some calculation in this type of question. So it is 100 pi by 3 radian per second. And once we calculate the omega s, now we can calculate the omega. What is the omega? Angular frequency in radian per second, rotor speed is omega s times 1 minus s. So it is 1000 pi by 3. Omega s is 1000 pi by 3 divide multiplied by 1 minus 0.03. I am giving each and every step explanation, otherwise I can skip these steps. I am giving each and every step for you calculation step, otherwise I can skip these step and give the direct answer. So what is the TR? PSH. Shaft power is equal to TSH 150 multiplied by omega. Omega R is 97 pi by 3. So it is, I am calculating and it is asking in the kilowatt. But our answer is in watt. So what we have to do? We have to divide by 1000 also. We have to divide by 1000 also because we have to give the answer in kilowatt. So it comes out 150. I am giving the answer 150 multiplied by 97 pi divided by 3000. 15 point. Yes, yes, Abhishek, you have given the answer correctly, bache, but it is asking in kilowatt. So 15 point. Yes, Abhishek has given the answer in kilowatt as well. So 15.236 kilowatt. Correct answer is 15.236 kilowatt. Very good, Abhishek. Very good. So correct answer is bache 15.236 kilowatt. I hope it is clear to everyone because question was not so much tough. Only little bit calculation is there, and these question can easily be done using the power flow diagram of the induction motor. Once you have the clarity about the power flow diagram of the induction motor, you can solve this type of question very easily. Now moving to the next question. This question is related to DC series motor. This question is of DC series motor. A 200 volt DC series motor runs at 1000 RPM and takes 20 ampere. Armature current is 20 ampere. N is the 1000 RPM. Combined resistance of armature and field. RSC plus RSA. Series field resistance plus armature resistance sum is 0.4 ohm. Assuming torque is varying as square of the speed, the value of the resistance to be inserted in series so as to reduce the speed of to 600 rpm. How much resistance we have to insert it in series of the series DC motor so that speed is reduced to 600 rpm. And torque is varying as the square of the speed. It is given. Torque is directly proportional to the square of the speed. So easy question you have to solve. So in the first case, supply voltage is given as 200 volt. And in the first case, if the motor is taking 20 ampere, speed is 1000 rpm. Speed is 1000 rpm. So if I solve, it is case 1, EB1. Case 1, when the armature current is 20 ampere and data is given as RSE, RSE plus RA. The sum of the series field resistance plus armature resistance is given as 0.4 ohm. The combined resistance of armature and field is 0.4 ohm. So RSE plus RSA is given as 0.4 ohm. And supply voltage, line voltage or supplied voltage VL is 200 volt. So we can calculate first case EB1. Back EMF in first case is VL minus IA1. फर्स्ट केस है तो इसे IA1 नाम दे रहे हैं. IA1 इंटू RA प्लस RSC. So VL is 200 volt minus IA is 20 ampere. RA plus RSC is 0.4. So EB1 we are getting as 200 minus 8, 192. 192 volt is the EB1. Now, in the second case, we have to insert a resistance. Supply voltage is same, RA plus RSC is same, but in the second case, we are inserting a resistance. And we very well know, we can write T is, we know very well, T is directly proportional to phi IA. So it can be, and phi for series in the series motor, flux is directly proportional to armature current. So it is a IA square. Torque for a series motor can be written as IA square. And it is also given. It is given as torque is directly proportional to speed square. Speed square. So we can write T1 upon T2 is equal to IA1 का square upon IA2 square is equal to N1 square upon N2 square, because it is given in the numerical. It is given in the question that torque is directly proportional to speed square. So T1 upon T2 is N1 upon N2 whole square. And if I equate these two equations, N1 square upon N2 square, so I can relate the armature current with the speed of the series motor. So IA, equating these two conditions, I can write IA1 upon IA2 is equal to N1 by N2. Now I can put IA1, N1, N2, I can calculate I2. Because IA1 is given 20 ampere, IA2 we have to calculate is equal to N1. First case speed is given as 1000 RPM and second case speed is given as 600 RPM. So IA2 we can calculate. IA2 is coming 12 ampere. IA2 is 12 ampere. Now once we calculate the IA2, we can calculate the EB2. What is the EB2? EB2 is VL minus IA2 second case into RA plus RSC plus R. External resistance I am adding R. I hope diagram is very clear. I am not drawing the diagram. Otherwise, if you say or comment, I can draw the diagram as well. So what is the line voltage? Line voltage in both cases is 200. In the second case, armature current is 12 ampere. RA plus RSC is given as 0.4 plus R external. It is the EB2. And EB2 we can write 200 minus 12 into 0.4. You can calculate easily. 12 multiplied by 0.4, 4.8 minus 12 R external. Okay, moving to the next question. So it is 12 into R external and it is the EB2. EB2. Now we can calculate EB1 and EB2 if I give the relation EB1 upon EB2, EB is directly proportional to phi n. Everyone knows EB is directly proportional to phi n. EB is equal to Z phi NP upon 68. So EB1 upon EB2 is phi 1 N1 upon phi 2 N2. Phi 2 N2. So it is phi 1 upon phi 2 can be written as I1 upon I2. I1 upon I2 into N1 upon N2. EB1 we have already calculated 192. EB2 we have to calculate EB2 into I1 upon I2. In the first case current is 20 ampere. In the second case current is 12 ampere. Into N1. Speed in the first case is 1000. Speed in the case is second case is 600. And if I solve, I am getting EB2 is 192 into 12 into 6 divided by 20 into 10. And if we calculate EB2, we can calculate, and EB2 we are getting as it is 68.4. EB2 we are getting 68.4. Now if I put the EB2, I get the answer. EB2 I get 68.4 is equal to 200 minus 4.8 minus 12 into R external. So R external is, I am getting R external as 12 into R external is 200 minus 4.8 is 195.2 minus 68.4. So R external I am getting, if you solve, R external I am getting as 192. Yes, it is 126.8 divided by 12. So easy. Calculation is so easy. Divided by 12, I am getting 10.56. 10.56 ohm is the correct answer. So correct answer of this question is, yes, 10.4 is the 10.56 actually Ashok I am getting. Or options are also 4 ohm, 10.5, 5.5, 5.5, or it is same 15.5. Let it be. So 10.5 is the correct answer. B option 10.5 is the correct answer. So DC series motor is important for the gate examination, because if you know the relation of the DC series motor, you can calculate. Again, I am explaining because this question was little bit lengthy. So I am once again explaining. First of all, I have calculated EB1 using the VL minus IA1 into RA plus RSC. I hope this should be clear. So VL is equal to IA1 into RA plus RSC. Abhishek has given sir EB2 is coming 69.12 or our case is 68.4. Okay, Abhishek, I am checking the calculation, bache. I am checking the calculation. So EB1 is the 192. Up to this point, uh, I think it is clear to everyone. Now moving to the second case. For the series DC motor, torque is directly proportional to phi into Ia. And for DC series motor, phi is proportional to Ia. Although I have not written this, but everyone knows before saturation, flux is directly proportional to armature current for series motor. So if phi is directly proportional to Ia, the torque is directly proportional to Ia square. So T1 upon T2, first case torque divided by second case torque is equal to Ia1 square upon Ia2 square. But in the question given, torque is varying as square of the speed. Means torque is directly proportional to n square, it is given. That depends on the load nature. So load is connected like this, the torque of the load torque is directly proportional to n square. So T1 upon T2 is equal to N1 by N2 ka whole square. If I equate these two conditions, I am getting Ia1 upon Ia2 is N1 by N2. First armature current is given first case speed is given, second case speed is given, so we can calculate the second case armature current as 12 ampere. Up to this point, I think there is no problem to anyone. Now I use the second case EB2 with external resistance. External resistance I am getting VL minus IA2 into RA plus RSE plus R external. So in the second case, armature current is 12, RA plus RSE is 0.4 plus R external. R external. So EB2 is equal to 200 minus 12 for the 48, 4.8 minus 12 external. Okay, it is now EB2. Abhishek is saying, sir, EB2, you have to just check. So what is the EB1? EB1 upon EB2 is equal to Phi1N1 upon Phi2N2 because back EMF is Z phi NP upon 68. So phi multiplied by speed. So EB1 upon EB2 is Phi1N1 upon Phi2N2. Phi1 upon Phi2 can be written as I1 by I2 into N1 by N2. So I1 is 20 ampere, I2 is 12 ampere, N1 is 1000 RPM, N2 is 600 RPM. EB1 is the 192 volt. So we can calculate the EB2. So EB2 is 192 into 12 into 6 divided by 200. So according to me, calculation comes out 68.4. But Abhishek is saying, sir, it is coming out 69.1. So Abhishek, I am checking the calculation once again because EB1 is the 192. We have already calculated. EB2 we have to calculate. I1 upon I2, 20 upon 12 into 1000 upon 600. So Abhishek, once again, bache, you should check. I think I am just again calculating 192 into 12 into 6 divided by 200. 69.1. Okay, okay. So there is little bit mistake. It is a 69.12 volt. Okay, okay. Ashok is saying, sir, take the question of power. Okay, okay. Ashok, definitely I will take the marathon of power system also. So Saturday I will take the marathon of power system. So Ashok, tomorrow I am taking the marathon of uh, reasoning and aptitude or any other subject I can take. Tomorrow I am taking the aptitude and reasoning, marathon, and after that tomorrow that is a Tuesday, and Wednesday I will take the digital electronics marathon. Wednesday I will take the digital electronics marathon. Every day I will take the marathon, and Friday I am taking the marathon of power system. Power system. So Friday I will take the marathon of power system. Thank you, Ashok. Thank you very much, bache. Thank you. So I will take the marathon for every subject. So now let's start the question. Next question. 2000 kVA three-phase alternators are operating in parallel and supply load of 1500 kVA at 0.8 lagging power factor. If one of the machine is operating at 0.6 power factor lagging and supplying 800 kVA, the output of the other machine. You have to calculate the output of other machine in kVA. So this question you have to solve. So 2000 kVA three-phase alternators are operating in parallel and supplying load. Total load is 1500 kVA at 0.8 lagging power factor. If one of the machine is operating at 0.6 lagging power factor and supplying 800 kVA, the output of the other machine is how much kVA? Easy question. You can simply solve. Total load is provided by the two alternator. One alternator is SA, second alternator is SB. SB. So what is the S? First, the total load is 1500 kVA, 0.8 lagging power factor. So total S is 1500 kVA and zero point 0.8 power factor lagging. Cos inverse 0.8. So student knows cos inverse 0.8 is I think 36.86, 36.87, and it can be written as in P and Q terms is S cos phi plus J times S sin phi. If it is written as S phi, it can be written as S cos phi. This is the P plus J times S sin phi. It is Q. P plus JQ. Because complex power we can add or subtract, but it must be complex. So it is coming 1500 cos phi is 0.8 plus j times 1500 sin phi. Sin phi is 0.6. Everyone knows if the cos phi is 0.8, sin phi is 0.6. And if it is lagging power factor, so it is the plus. Means alternator is providing the reactive power. Active power as well as reactive power both are जो है supplied by the alternator. So what is the correct answer? S. S is equal to in the first case S is equal to 1500 into 0.8 is 1200 plus J 1500 into 0.6. 1500 into 0.6 is 900. 900. It is the P plus GQ. P plus JQ. It is the first case. Now the S1 first load. First load is 800 kVA and power factor is 0.6. And if the power factor is 0.6, it can be written as 800 angle 53.13. 53.13. So what I am getting? I am getting 800 multiplied by 0.6 plus j times 800 multiplied by 0.8. So S1 I am getting 480, 8 6 are 48, 480 plus j times 8 8 are 64, 640. It is the P1 plus JQ1. P1 plus JQ1. Yes, Sai Kishore is giving the answer 720. I think almost 720 is the correct answer. Very good. Sai, I am also calculating, bache. So what is the S? S is equal to S1 plus S2. So S can be written as P plus JQ. P plus JQ is equal to P1 plus JQ1 plus P2 plus JQ. So we can calculate P2 plus JQ2 is equal to P plus JQ minus P1 plus JQ1. And if I put the value, I get the answer. It is the 1200 plus J 900 minus P1 480 plus J 640. So we are getting 1200 minus 480 is 720 plus J 900 minus 640. So it is 260 is the answer. But we have to take the modulus because it is asking the overall KVA. So in the KVA we have to take the modulus. So what is the modulus? S2 is equal to modulus of P2 plus JQ2. Since it is NAT, Abhishek, your answer is correct, bache. But we have to take the only modulus. The angle is not required because it is a NAT question. So we have to give the modulus of this answer. And what the modulus I am getting? I am solving. Yes, I am getting 70, 760, 765 0.5 kVA. Abhishek Bache, you have to check. You have to check. According to me, correct answer is 765.5 kVA. And if you calculate the power factor, although power factor is not required because only magnitude is required. Abhishek Ashok is also given 963. I think 963 is not correct answer. 765.5. You should check the calculation because if you take the modulus, S is equal to under root. Everyone knows S is equal to under root P square plus Q square. If you use this formula, you can calculate the overall load. Abhishek, are you checking, bache? According to me, correct answer is 765.5. 765.5 kVA is the correct answer. And if you calculate the power factor, you can calculate the power factor as well. 720 divided by 765. You can calculate the power factor as well. Yes, Sai Kishore is also giving the correct answer, 765 now. Okay. Sai, your answer is correct. Abhishek, Ashok, your answer is correct. Abhishek, you should check, bache. You should check your answer. According to me, it is coming 765.5. So correct answer is 765.5 is the correct answer. Okay, moving to the next question. Yes. Abhishek is also giving the correct answer. Very good, bache, very good. So a 50 kilowatt, 400 volt, three-phase synchronous motor is operating at full load with an efficiency of 92%. If the field current is adjusted to make its power factor zero point 0.8 leading, estimate the armature current. Okay, no problem, Abhishek, no problem. But some little bit calculation mistake only. Okay, so try to give the answer a 50 kilowatt, 400 volt, three-phase synchronous motor. And if it is a motor, it is giving as the output power. If it is motor, always giving the output power. If it is an alternator or generator, it is giving the input power. So if it is a synchronous motor, it means P output is given and efficiency is also given 92%. And line voltage is 400 volt and it is a three-phase synchronous motor and power factor is zero point 0.8 leading. So you can calculate the armature current using the formula P input. P input is equal to root 3 VL cos phi. Using this formula, you can easily calculate the armature current IL. Armature current is nothing but it is the line current. IL you have to calculate. And power input is the power output divided by efficiency. Because efficiency is given as, for this question, efficiency is 92%, that is 0.92. 0.92. And output power is given as 50 kilowatt. Output power is given as 50 kilowatt. So efficiency we must know the power output divided by power input. So from this equation we get the power input is equal to power output divided by efficiency. So 50 divided by 0.92 kilowatt. Yes. Gajendra, very good, bache. If connection is not given, always assume the star connection. Very good. Very good. So if the efficiency is given as 90 upon 0.92 is the input power, now we can use the input power as root 3 VLIL cos phi. And since power is in kilowatt, so we must convert into the watt. So 50 into 1000 divided by 0.92 is equal to root 3. Line voltage is 400 volt. IL we have to calculate. Line current is equal to the armature current for star connection into cos phi. Cos phi is given as 0.8. So we can calculate the IL. And IL we are getting 50,000 divided by root 3 into 0.92 into 400 into 0.8. And Ashok have already given the answer. I am also checking. It is coming 98 ampere. 98 ampere. Okay, I am just calculating. Otherwise, I think Ashok answer is correct. I am also calculating. 98.05. अभिषेक बिल्कुल सही बच्चे. Correct answer is 98.05 ampere. But option is given as 98, so we take the 98. Nearest answer or closest answer is 98 ampere. So we must take the 98 ampere for this question. Okay, moving to the next question. 98 ampere is the correct answer of this question. Okay, it is oral question. This question is an oral question. A 8-pole DC generator has 600 armature conductor and flux per pole is 0.070 Weber. The ratio of EMF generated with the winding wave connected in one case and lap connected in the second case will be. Means we have to calculate the ratio of generated EMF E1 upon E2. In the first case, it is connected in wave winding, and in the second case, it is connected as lap winding. You can give the answer directly because only number of parallel paths change. Number of armature conductor remains same, flux per pole remains same, everything remains same, number of pole remains same, flux per pole remains same. So we know EG is equal to Z phi NP upon 68, where A is the number of parallel paths. A is the number of parallel paths. So in the first case, for wave winding, A is equal to 2. For wave winding, yes, Gajendra, your answer is correct, bache. For wave wound, A is equal to 2. And for lap wound, A is equal to P. Or P is equal to 8. So A is equal to 8. Yes. Wave upon lap is equal to P by 2. Very good, bache, very good. So EG wave divided by EG lap is equal to A lap divided by A wound. In the lap wound, it is 8, and in the wave wound, it is 2, or P by 2. So it is 4. Correct answer is 4. Very good, very good. Sai is saying, sir, please increase the speed. Okay, bache. So, next question. Try to give the answer of this question. A 100 kVA 1000 volt oblique 400 volt single phase transformer when excited at rated voltage on high voltage side draw a no load current of 3 ampere and power factor is 0.75 lagging. If it is excited from the low voltage side at rated voltage, then the no load current and power factor. You have to calculate the no load current, then no load current and power factor. So if it is excited by high voltage side, no load current is 3 ampere. If it is excited from the high voltage side, what is the no load current and what is the no load power factor? You have to calculate. Means you have to calculate no load current in the when excited by from low voltage side and what is the low power factor, no load power factor in the second case. And high voltage side is 1000 volt, low voltage side is 400 volt. So everyone knows if it is excited by low voltage side, current increase and current increase 2.5 times because 1000 upon 400 is 2.5. So I am calculating in the first case when it is excited at high voltage side. In the first case when it is excited by high voltage side, so voltage is 1000 V1, 1000 volt, and current no load current IO1 is 2.5 ampere. When it is excited from low voltage side, so voltage V2 is 250. It is given as 250 or 400, sorry. It is given as 400. 400 volt. So, what is the IO2? IO2 we have to calculate. So, V1 IO1 is equal to V2 IO2. So, V1 is 1000 into 2.5 is equal to V2. V2 is 400 into IO2. So, IO2 is 1000 into 2.5 divided by 400. In the first case, it is given as 3 ampere. Sorry. This current is given as 3 ampere. You should change the data. No load current is given as 3 ampere. 3 ampere. So if you write, so it is coming 2.5 multiplied by 3, 7.5 ampere. So correct answer is 7.5. Sai is asking, sir, what is the, how we calculate the power factor? So no load power factor remains same whether it is excited at high voltage side or at low voltage side. No load power factor does not change whether it is excited by high voltage side or excited at the low voltage side. So correct answer is if it is 0.75 lagging, it remains same 0.75 lagging and current is 7.5 ampere. So power factor, no load power factor does not change whether it is excited at high voltage side or low voltage side. Power factor is independent. No load power factor is independent. So cos phi 1, phi O1 is equal to cos phi O2. No load power factor remains same because this load is VI cos phi. VI cos phi. So cos phi remains same. Cos phi remains same. In both cases, cos phi remains same. Whether it is excited at low voltage side or high voltage side, losses remain same. At the no load transformer loss remains same. That is why power factor remains same. This question is related to auto transformer. This question is of the auto transformer. A 2500 2500 oblique 250 volt 25 kVA transformer is connected as an auto transformer to 250 oblique 2750 volt. Then its rating would be. You have to calculate the rating. What is its rating? How much power is drawn conductively? How much power is drawn inductively? You have to calculate how much power it is drawn inductively, how much power drawn conductively. It is 2500. This is 2500. I am changing it. It is basically mismatch. 2500 oblique 2750. This is the rating because options are given up to for this rating. Primary voltage is 2500 or auto transformer secondary voltage is 2750 volt. So what is how much power is transferred conductively? How much power transfer inductively? You have to calculate. So a 2500 oblique 250 volt 25 kVA transformer is connected as an auto transformer. So the rating of the auto transformer is 2500 oblique 2750. So how much power is transferred inductively? How much power transfer conductively? And how much total transfer power? Total transfer power. So I am solving this question. If I solve this question, so in the first case, transformer is a two winding transformer. In the first case, transformer is two winding transformer. First case, primary voltage is 2500. Primary voltage is 2500 volt and secondary 250. It is 250 volt. And since it is a 25 kVA transformer, so primary current is 10 ampere and secondary current is 100 ampere. It is a two winding transformer. The data is given as 25 kVA. Primary voltage is 2500, secondary voltage is 250 volt. And it is connected as a auto transformer. And rating of the auto transformer is 2500. Primary voltage is 2500 and secondary voltage is 2750. So means voltage is additive. Both the voltage at the secondary side is additive. So how much draw the winding? As an auto transformer, the winding must be connected like this. Both winding in the series, primary as well as secondary, and dot polarity must help each other because both the voltage are additive to each other. So it is 250 and it is the 2500. This winding current is 10 ampere and this winding current is 100 ampere. And this is the auto transformer connection. So primary voltage is 2500 and secondary side voltage is 2750. And this current is 100 ampere and this current is 100 plus 10 because it is 100 outgoing, it is 100 ampere outgoing and it is 10 ampere this. So 10 plus 100 is the 110 ampere. So now how much power is transferred? The power transferred is 2500 into 110. That much power is either you can calculate primary side or secondary side. Both are have the same power. So rating of the transformer, rating of auto transformer or inductive plus conductive. Rating of auto transformer. I have not used any formula. Some students use the formula for auto transformer, but if you see the connection diagram, you can easily solve the transformer questions. So rating of auto transformer is V1 I1 is equal to V2 I2. V1 is 2500 into I1 is 110 divided by 1000 because I am calculating the rating in kVA is equal to V2 I2. What is the V2? V2 is 2750 into I2. I2 is 100 ampere divided by 1000. That much of kVA. So correct answer is 275 kVA. This is the 275 kVA is the correct answer. Because if you use this transformer, if you connect as an auto transformer of the rating 2500/2750 volt, total power transferred is 2750. So A is wrong, B is wrong. But this power is total power, means inductive plus conductive. This power is inductive plus conductive. So how much power is conductive transfer? Common winding. Common winding power is transferred conductively. This common winding rating is power transfer conductively. So conductive power is 2500 multiplied by 10. So power transfer conductively, power transferred or it may you can calculate directly because the rating of the transformer is power transfer inductively always. So this power is inductively transferred 25 and remaining increment power is the conductively. So 2750 kVA can be written as 250 kVA plus 25 kVA. And rating of the transformer is always transferred inductively. This much power is always transferred inductively. So remaining power transfer conductively. That is also the calculation. You can calculate The conductively power is total power transferred minus rating of the transformer. Because if you use the transformer to make the auto transformer, that much power always transfer inductively. So 20, out of 275 kVA, 25 kVA transfer inductively. So remaining power is guaranteed transfer conductively. So out of 275 kVA, 25 kVA is transferred inductively and 250 kVA transfer conductively. Or you can calculate the rating of common winding. Rating of common winding also give the power transfer conductively. So power transfer conductively is total power transfer minus power transfer inductively. Power transfer inductively. And power transfer inductively is always rating of two winding transformer. Rating of two winding transformer. So it is 275 minus 25. That is the 250 kVA. Or alternatively, you can calculate the power transfer conductively is the power rating of the common winding. And common winding between the primary and secondary is 2500 multiplied by 10. So correct answer is D. D is the correct answer of this question. Now moving to the next question. Try to give the answer of this question. The torque developed by a three-phase 400 volt induction motor is 100 Newton meter. If the applied voltage is reduced to 200 volt, the developed torque is. In the first case, voltage given to the induction motor is 400 volt. In the second case, if voltage is reduced to 200 volt supply voltage, how much torque is? How much the developed torque is? So everyone knows developed torque, electromagnetic torque is directly proportional to terminal voltage square or phase voltage square. Developed torque is or electromagnetic torque is directly proportional to voltage square. Everyone knows this formula. So TE1 first case developed torque divided by second case developed torque is equal to V1 square divided by V2 square. Yes, Gajendra, very good, bache. You have given the correct answer. So in the first case, developed torque is 100. In the second case, it is called TE2 divided by. In the first case, it is 400 upon 200 whole square. So TE2 is 25 Newton meter. Very good. So it is easily question Newton meter. One mark question it may come in the gate. Pinky is asking sir this lecture for EC. But in EC it is only in ESC, not in gate. Pinky, for your information, machine is in ESC electronics. In ESC electronics, not in gate. So Pinky, I am taking the marathon, bache, digital electronics day after tomorrow. So on Wednesday, I will take the digital electronics marathon. Tomorrow, I will take the aptitude and reasoning marathon. So you may join 8 to 10 tomorrow or day after tomorrow. Okay, science saying the next one. Okay, bache, this is the next question. The maximum torque of a three-phase squirrel cage induction motor is 4 times the full load torque and starting torque is 1.6 times the full load torque. Neglect the stator resistance, the slip at maximum torque. You have to calculate the SMT. Slip at maximum torque you have to calculate. Okay, Pinky. So, bache, join tomorrow at the 8 p.m. I am taking daily marathon, either for electronics or electrical. Most of the subjects are common, but two or three subjects are the dedicated for electrical. So today I am taking the electrical marathon. Tomorrow I will take the reasoning and aptitude, and the day after tomorrow I will take the digital electronics marathon. So what is the SMT you have to calculate? So I am solving this question. The data given is the maximum torque T max Maximum torque is given as 4 times TFL, 4 times of the full load torque. And starting torque, EST, starting torque is given as 1.6 times TFL. These two conditions are given. These two conditions are given. Now we use the formula. What is the formula? Formula is EST divided by T max is equal to 2 upon 1 upon SMT plus SMT upon 1. Because starting slip is 1. Where everyone knows slip at starting is 1. Because NR is 0 and slip is 1 at the starting. So if you use T starting is 1.6 times TFL and T max is 4 times TFL is equal to 2 upon SMT we have to calculate. So it is so easy. SMT whole square plus 1 into SMT. It is a quadratic equation now, everyone can solve. So it is 4 4 ja 16, 4 10 ja or 2 by 5. So it is 2 cancelled out. So it is SMT square plus 1 is equal to 5 SMT. Now using the Dharacharya, you can calculate SMT square minus 5 SMT plus 1 is equal to 0. So what is the SMT? SMT is equal to, it is the 5 SMT. So SMT slip at maximum torque is minus B. 5 plus minus B square. 5 square 25 minus 4 AC 4 upon 2. I hope everyone can calculate. Slip is always less than 1. So it is minus 5 minus under root 21 divided by 2. I hope everyone can solve. So what is the correct answer? I am solving. Point 2. SMT is point, Ashok is giving 0.25. I think I am also checking. According to me, it is coming 0.2, 0.28 or 0.21. According to me, SMT is coming 0.21. Yes, 0.21 is the correct answer. If you solve EST upon Tmax, TST is the 1.4 TFL upon 40 TFL, 4 TFL. 0.208. Yes. Yes, exactly. Abhishek, I am getting 0.208. Bilkul sahi. So 0.208 is approximated as 0.21 because exactly it is coming 0.208 up to 2 decimal point. I have approximated as 0.21. Very good, bache. 0.21 is the correct answer. So slip at maximum torque is 0.21. Sai is saying, Sai, I think this formula is very important. If you are asking about how to remember, this formula is very, very important. Or you may remember like this. You may remember like this, sign TFL. TFL upon Tmax. I hope you already know this formula. 2 upon SFL upon SMT plus SMT upon SFL. This is the formula basically. But if you know here starting torque, slip is 1. So if you replace TFL with TST, SFL is replaced by 1. I hope this formula is very, very important in the induction motor. Or I can derive. If you want, I can derive this formula in the theory lecture. If you insist me that sir, take the theory lecture of the induction motor, I can take the theory lecture as well. But you must remember this formula. You must remember this formula. It is important one. Okay, try to give the answer of this question. It is the uh, tertiary winding also there. Okay, fine. So try to give the answer. Below figure shows an ideal 3 winding transformer in which windings are wound in the same core, same iron core. The turn ratio N1 is to N2 is to N3 is 9 is to 3 is to 1. A resistance of 20 ohm is connected across the winding 2. It is the winding 2. A capacitor of reactance. It is not resistance. It is the reactance of 5 ohm. 5 ohm. It is the reactance is connected across the winding 3. Winding 1 is connected across a 400 volt AC supply. It is the RMS value of the primary voltage. It is the 400 volt. So if the voltage is the same phase, V1 is 400 angle 0 degree. So then the supply current phasor I1. You have to calculate the I1. So it is so easy. First you calculate the I2 and I3 and then transform the current in the primary winding. First you calculate the I2 and I3 and then transform the current into the primary side. And I2 dash plus I3 dash is the I1. I hope everyone knows. Yes, yes, yes. So this question as well as the previous one question is frequently asked in the examination. I have taken the most important question which is very frequent in the gate examination. So these type of questions are for above average students and you get the good rank if you practice these type of questions for the machine as well as the power system. So I will take the core subject as well. Every day I am taking one marathon. Okay, so what is the answer? Try to give the answer. So V1 is given, we can calculate the V2. V1 by V2 is N1 by N2. Everyone knows. First I am calculating the I2. For I2 I have to calculate the V2. So I am solving this question. V1 is given as 400 angle 0 volt. So what is the V2? V1 by V2, everyone knows N1 by N2. Because it is a ideal transformer. So what is the V2? V2 is N2 by N1 into V1. N2 by N1 is given as 3 by 9. N1 is to N2 is to N3 is given as 9 is to 3 is to 1. It is given like this. So N2 is 3, N1 is 9 into 400 angle 0. So it is 400 by 3 angle 0 degree. And once we calculate the V2, we can calculate the I2. I2 is V2 by R because it is a pure resistive circuit. So I2 is V2 by R. V2 we have calculated 400 by 3. 400 by 3 angle 0 divided by R. What is the value of resistance? 20 ohm. So I am getting this is 20 by 3 angle 0 because in the pure resistive load current is always in the same phase with the voltage. So secondary current is 20 upon 3 angle 0. Similarly, I can calculate the V3. V1 by V3 is equal to N1 by N3. So V3 is, if I calculate the V3, is N3 by N1 into V1. N3 by N1 is 1 by 9 into 400 angle 0. So it is 400 by 9 angle 0. Once we calculate the V3, what is the I3? I3 is V3 by Z3. And in this third branch, it is a pure capacitor. So it is 400 by 9 angle 0 divided by minus J5. Everyone knows capacitor in the phasor form can be written as minus J5 or 5 angle minus 90. So 400 divided by 5 is 80 by 9 angle 90 degree. So we calculated the I2 and I3. If anyone has the doubt regarding the I2 and I3 can be asked. But these are the at the secondary and third side. But we have to calculate at primary side. So we have to refer this current at the primary side. because we have calculated the I2 and I3. I2 have come, I2 is coming as 20 by 3 angle 0 degree. And what is the I3? I3 is coming as 80 by 9, 80 by 9 angle plus 90 degree. These current we have already calculated, but we have to add I2 dash and I3 dash to calculate the I1. So what is the I1? I1 is nothing but primary current is equal to I2 dash current referred, secondary current referred to primary side plus tertiary current referred to primary side. I hope you already know. And current is the inverse ratio of the term. Current voltage ratio is the directly proportional to turn ratio. Current ratio is inversely proportional to current ratio. So what is that? I2 dash current referred to primary side divided by secondary current is equal to N2 by N. Because I2 dash is the secondary current referred to primary side. And it can be written as I2 dash is equal to N2 by N1 into I2. What is N2? N2 is 3 by 9. 3 by 9 means 1 by 3. Into I1. I1 is 20 by 3. Everyone can refer. I think it is so easy. Angle 0 plus this current I3 dash. I3 dash is equal to N3 upon N1 into I3. So it is coming. Primary side we are referring. And in the primary side, if I refer 1 by 9 into 80 by 9, angle 90 degree. So it is coming 1 by 9 into 80 by 9, angle 90 degree. That is the answer. If you solve, you are getting 20 by 9, angle 0 degree plus 80 by 81, angle 90 degree. Yes, so it is 20 by 9 plus 80 by 81 J. Because 90 can be written as 80 by 81. That is the answer. Abhishek Bache, you have calculated. I think you have not referred. Okay, you have wrongly referred. Abhishek, you have wrongly referred. Current ratio is inversely proportional to turn ratio. So correct answer is 20 by 9 plus 80 by 81. So correct answer is 20 by 81. 20 by 81 you have to take common. If you take the 20 by 81 common, if you take the 20 by 81 common, it is 9. It is 9 plus 4 j times 4. So correct answer is 20 by 81 bracket 9 plus j4. This is the correct answer. So 20 by 81 bracket 9 plus j4 is the correct answer. 20 by 81 9 plus j4, C option is correct answer. I hope everyone is getting. If anyone have the doubt, kindly ask. It is so easy question. First, calculate the V2, V3 in terms of V1 because turn ratio is given. Then calculate the I2 and I3 and then refer to primary side. I think this question is so simple. Only little bit calculation lengthy. Otherwise, concept wise, it is so easy. V1 is given. Using the turn ratio, you can calculate the V2 and V3. After getting the V2 and V3, we can calculate the I2 and I3 at the secondary side and tertiary side. Then refer the current to the primary side. And some of the referred current I2 dash and I3 dash is nothing but it is the I1. Because primary current is supplying the load current. So I1 dash is nothing but it is I2 plus I3. I2 dash plus I3 dash. Yes, Abhishek. So correct answer bache 20 by 9 plus 80 by 81 J. I hope it is clear to everyone. If anyone has the doubt, kindly ask. Otherwise, moving to the next question. Sai, Gajendra, Abhishek, Bache, everyone, Ashok. If anyone has the doubt, kindly ask, Bache. Otherwise, moving to the next question. Okay, try to give the answer of this question. A three-phase 450 volt, 50 hertz, 6-pole induction motor develops 5.2 kilowatt at the shaft with 800 watt of the mechanical loss at 980 rpm. The rotor copper loss is. you have to calculate the rotor copper loss. What is the rotor copper loss? You have to calculate. Sai, it is the next question, bache. Try to give the answer of this question. Very good question it is. This question can be solved using the power flow diagram of the induction motor. Again, this question can be solved using the power flow diagram of the induction motor. Okay, Sai, I am waiting, bache. I am waiting. You can give the answer of this question. I am also solving. I am also solving. So, mechanical power developed PM. PM is equal to PG minus SPG. Air gap power minus rotor copper loss SPG. So, it can be written as 1 minus S times PG. Gajendra have given the answer. Okay, Gajendra, I am also calculating, bache. So PM is equal to 1 minus SPG. And rotor copper loss is equal to S times PG. S times PG. So PG can, rotor copper loss is S times PG. And PG can be written as PM upon 1 minus S. So S into PG. PG can be written as PM upon 1 minus S. That is the answer. So rotor copper loss is SPM upon 1 minus S. Rotor speed is given 980 RPM. So you can calculate the slip. Frequency is 50 Hertz. Number of poles is equal to 6. So synchronous speed is equal to 120 F upon P. So 120 into 50 upon number of pole is 6. So NS is equal to 1000 RPM. And slip is equal to NS minus NR upon NS. 1000 minus 980 upon 1000. So it is coming 0.02. Slip is coming 0.02. Now you can calculate the PM. How can calculate? Soft power minus mechanical loss is equal to PM. So mechanical power developed PM is equal to PSH plus mechanical loss. PSH is given as 5200 plus 800. So it is 6000. So mechanical power developed is 6000. Sai Kishore is giving the answer. Okay, Sai, I am also calculating. So rotor copper loss is 1 minus S upon S times PG. PM, sorry. 1 minus SPM upon 1 minus S. It is SPM upon 1 minus S. Rotor copper loss is SPM upon 1 minus S. So I am getting 0.02 slip into PM. PM is 6000 divided by 1 minus S. 1 minus 0.0. So I am getting it is the 120 divided by 0.98. So it is 122.4. Very good, bachcho. 122.44 watt. So Gajendra, you have to check, bache. Uh, it is SPM upon 1 minus S. I think Gajendra have neglected the 1 minus S value. So Gajendra, it is bache PM, not PG. It is the PM, not the PG. So PM is equal to soft power plus mechanical loss. So it is the 6000. And the rotor copper loss is SPM upon 1 minus. I hope it is so easy. Just you have to use this formula. And these two formula you can use using the power flow diagram of induction motor. Power flow diagram of three-phase induction motor. Yes. So using this formula, you can easily calculate. Okay. Moving to the next question. Try to give the answer of this question. This question may be a network question or may be a synchronous conduction. When the induction motor or synchronous motor working in a leading power factor over excited region, it is working as a condenser. So you have to calculate an alternator supplying a 600 kilowatt load at 0.75 power factor lagging. Has its power factor raised unity by means of overexcited synchronous motor. Means load synchronous motor is working as a load and it is working as a synchronous condenser. At a constant armature current, the reactive power supplied by the motor and the power factor of operating are respectively. So easy. It is so easy. You can easily calculate. So zero power factor lagging is the wrong answer because a synchronous motor working as a leading power factor can acting as a leading power factor. So lagging power factor is the wrong answer. Zero, every option is the zero means it is working as a synchronous condenser. So how much reactive power is supplied by the alternator is absorbed by the synchronous motor. So you just calculate the reactive power of the alternator, and that much reactive power is absorbed by the synchronous motor. Because zero power factor becomes synchronous condenser can work as a zero power factor when it is working as a synchronous condenser. Because 90-degree leading, cos phi is cos 90 becomes zero. So it is like this. There is a alternator. There is a alternator, and it is alternator or generator. Power factor, it is supplying 600 kilowatt load, any load there, and we have to connect a synchronous, it is the load, and load power factor is 0.75 lagging, 600 kilowatt load, and power factor of the load is 0.75 lagging. So to compensate, we have to use a parallel synchronous motor. Synchronous motor. So how much reactive power is supplied by the synchronous motor so that the supply power factor becomes unity. Supply power factor becomes unity. We have to make the supply power factor unity. So to make the supply power factor unity, how much reactive power is supplied by the synchronous motor? So it is so easy. What is the load reactive power? That much of reactive power is supplied by the condenser. So alternator will give the pure power P, no reactive power, power factor become 1. So it is so easy. So it is the 600 and 0.75 power factor. So S is equal to S cos phi is equal to P is equal to P. So F cos phi is equal to P. So P is given as 65, 600 kilowatt. S we have to calculate into cos phi. Cos phi is given as 0.75. So what is the S? S is equal to P upon cos phi. P is 600 upon 0.75. Yes, yes. Sai, I think, bache, your answer is correct, bache, Sai. So 600 divided by 0.75, it is 800 kV. S. How much reactive power? Reactive power of the load Q is equal to S sin phi. So it is 800 into sin phi. And if you calculate the sin phi, it is coming 0.66. Sine phi is 0.6614. And if I multiply it with S, so it is 529.15 kVAR. So it means this load has, if I write this load as, load can be written as, load can be written as 600 plus J times 529.15. That is the load. So to make the power factor unity of the alternator, this much of reactive power is supplied by the condenser. So to make the power factor unity, that much of power means this is the load power 600 plus J 529.15 minus J 529.15. That much of reactive power is supplied by the synchronous condenser or synchronous motor working as a synchronous condenser. And everyone knows the theory when synchronous motor is working in a overexcited region, so it will behave like a synchronous condenser. So it will supply the reactive power to the load. And total reactive power supplied by the alternator becomes zero. So alternator will provide the reactive power zero. And when alternator is providing the reactive power zero, power factor of the alternator become or overall power factor become 1. Yes, very good बच्चे, very good. बिल्कुल सही, बिल्कुल सही. Sign very good बच्चे, very good. If the power factor is made at the value other than unity, yes, yes, Gajendra, this is a very good question. I will take in the another जो है marathon. Certainly, I will take in the power system. This type of question is power factor is not unity, other than unity. How easily or how speedily we can solve this type of question. So, Gajendra promised, Bache, I will take this type of question either in the network marathon or in the power system marathon. Because this type of question is very good question if we have to make the power factor other than unity, not the unity. Because in the unity case, it is so simple because the total reactive power becomes zero, so we can calculate easily the reactive power. But if the power factor is not unity, it is other than unity, then how we can solve? It is a good question. So Gajendra, it is noted, Bache. I will take this question in the next marathon. Okay, so now I am winding this session. I am giving one or two questions as a homework. Try to solve this question. So this question is so easy. You can give the answer here. A 6-4 50 Hz three-phase induction motor has low rotor reactance per phase equal to the 4 times of the rotor resistance. The speed at which maximum torque develops. The speed at which maximum torque develops, it is so easy. So you can calculate. Sai is asking power electronics marathon completed. Sai, already I have taken one power electronics marathon. But in the coming days, I will take 2 or 3 marathon also. Because it is not the only marathon I am taking of for electrical machine. I will take my basically plan is I will take 4 to 5 marathon of each subject. 5 to 4 marathon for electrical machine, power system, power electronics. I will take more than 4 or 5 marathon because I am taking daily marathon. So I will take. I have already taken one power electronics marathon, but in coming days I will take more marathon of the power electronics machine and power system. Daily marathon is 8 to 10 p.m. 8 to 10 p.m. is the daily marathon time I am taking. Thank you, Sai. Thank you, Bache. So easy. So you can solve this question. Daily I am taking the marathon. Thank you, so thank you, Bache. Thank you very much. Thank you. Okay, okay. It is just to your increase your rank. My motive is now how can I improve help students to improve the rank. So if this question is very easy, I am solving. I am solving this question. It is given as SMT because everyone knows speed at maximum torque. If I calculate speed at maximum torque, omega max RPM. It is asking RPM. So NMT is equal to 1 minus SMT multiplied by NS. And what is the SMT? Slip at maximum torque is R by X. R by X. So resistance, reactance is 4 times the resistance. So X is given as 4R. Reactance is given as reactance per phase, rotor reactance per phase 4 times to the rotor resistance. So it is R by 4R, that is the 1 by 4, means 0.25. And if SMT is 0.25, you can calculate the NMT. What is the NS? NS is 120 F by P. Yes, yes, fine, okay. In the next marathon, I will take higher speed. I will make the higher speed, no problem, bache. So it is 120 multiplied by 50 divided by 6, that is the 1000 RPM. And if NS is 1000 RPM, it is NMT is 1 minus 0.25 multiplied by 1000. So it is 750 RPM. So I want to inform you, my students, that so far I have taken 2 marathon of network. 2 marathon I have already taken in my channel. You can go to the channel to see 2 marathon of network, 2 marathon of control. I have taken 2 control marathon, 1 analog electronics marathon, 1 digital electronics marathon, 1 mathematics marathon, 1 mathematics marathon, and 1 power electronics marathon. These marathon I have taken. Yes, yes, Sai, you can check, but these marathon I have already done. These marathon I have already completed so far. 2 marathon of network, 2 of control system, 1 of analog electronics, 1 of digital electronics, 1 of mathematics, and 1 of power electronics. And it is one of the machine. Today it is the one of the machine. These marathon so far I have taken, and I will take daily marathon. And 2 questions I am giving as a homework. You should note down. This question you should do as a homework. This question I am giving you as a homework. Try this question. This question I am giving as a homework. If you have any problem, I will solve this question in the next class or in the Telegram channel. I will give the solution on the Telegram channel of this question. If you ask, this question I am giving, and this is the second question. Second question as a homework. It is the second question. You can note. You can take the screenshot. This is the second homework question. And this is the third homework question. These 3 questions I am giving. Bye, Sani, bye, bache. You may note down these homework questions if you want. Otherwise, you can leave. These 3 questions as a homework, and these are the links of my YouTube channel. Kindly subscribe, Telegram channel, Facebook and Gmail ID. If you have any doubt, you can ask. And in the last, like my session, share the session with your friends, and subscribe the channel. If you like my teaching, you should subscribe my channel. It is my humble request to my all students. Thank you everyone. So now I am winding this session.